GCSE math series. Today we're going to be taking a look at exam style questions for our probability trees topic. So before I get started, I'd strongly advise you guys to check out my revision style video for this topic so that you can use this video to consolidate your knowledge so that you can commit it to your long-term memory. Also, shout out to Maths Genie for providing the content today, as I am answering their questions, so please make sure to check them out as well. So, getting started, we are told that John plays a game where he can win, draw, or lose. So, there's three possibilities. The probability that John wins any game is 0.5. So, first and second game, that basically means it's irrelevant. So, the probability that he wins any game is 0.5. So, a win is 0.5, I'll write that in there. A win is 0.5 here, I'll write that in there. 0.5 is a win there. Right. Now it tells us that the probability that John draws any game is 0.3. So I'm going to write that in here. 0.3, 0.3, and 0.3. Now it tells us that John plays 2 games and we need to complete the probability tree diagram. Okay, so we know that in any situation, so in any event, the probabilities are going to add to 1. So looking at the first game as our first event, we know that the probabilities that he wins, draws, and loses will all add up to 1. Hence, we can say that 0.5 plus 0.3 plus x is equal to 1. Therefore, solving for x, we'll have 1 minus 0.5 minus 0.3, and we'll get x is equal to 0.2. Therefore, in this box here, we can write that x is that the probability that he loses is 0.2. Now, we also know we can fit in 0.2 here, 0.2 here, and 0.2 here. This is because in each one of these branches here, he can either win, draw, or lose, meaning that the total probabilities will have to equal 1 in every single one of these branches. Because the only outcomes are win, drawing, and losing, hence the total probability of each one of those situations occurring should equal to 1. Therefore, when we have 0.5 and 0.3 consistent throughout any game, 0.2 must also be consistent, as always the score will add up to a total of 1. Moving on to the second part of this question, work out the probability that John wins both games. So, remember, we have to first follow the paths, so win, and we have to multiply the probabilities of them. So 0.5 times by 0.5. And this is going to give us a score of 0.25. So the probability is 0.25 or a quarter. Moving on to the next question. Mimi has 2 bags. In the first bag, there are 3 red balls and 7 green balls. In the second bag, there are 4 red balls and 5 green balls. Mimi takes out at random a ball from the first bag and then takes out a random from the second bag. Work out the probability that Mimi takes 2 green balls. So, first things first, we're going to have to draw our probability tree diagram and say, okay, this is our first bag and this is our second bag. Now, there's 2 possibilities in this situation. We first have our green balls down here and we have our red down here. Now, in the second bag, we also have 2 more possibilities. So we have our red bag and our green bags. Then filling in our probabilities, it tells us in the first bag there's a total of 10 bags because it's 10 balls, sorry. So we have a total of 10 because 3 red plus 7 green, so 10. The probability of picking out a red ball, therefore, is going to be 3 out of 10. So 3 out of 10 is going to go here. And therefore, 7 out of 10 is going to go here. Looking at the second bag, there's a total of 9 balls, with the probability of picking out a red going to be 4 out of 9. And the probability of green going to be 5 out of 9. And then we can fill this in down here also. That is our completed probability tree diagram. We are told to work out the probability that Mimi takes 2 green balls. So we have to follow the path of Mimi choosing 2 green balls. Therefore, we get 7/10 times, we remember, along the branches. 5/9 is going to be equal to 35 over 90. 35 over 90 is going to simplify to 7 over 18. And that is the probability that we are looking for. Okay, now looking at this question, we're told Joe is going to play 1 tennis match and 1 match of squash. The probability that she'll win the tennis match is 4/5. So we can fill this in. We can see that this is tennis, and Joe winning, we're told, is 4/5. We know that in terms of the event, the total probability is going to be equal to 1. So the probability that Joe does not win is going to be equal to 1 minus 4/5, which is equal to a fifth. So we can fill in a fifth here as such. The probability that she'll win the squash match is 7/10. So we can fill this in here. 7/10 and 7/10. We also know that the total is going to be 1 once again for each event. So we can fill these two values in to be 3/10. Okay, we've completed our probability tree diagram, and now we're told to work out the probability that Joe will win both matches. So we follow our line of Joe winning both matches, and we get 4/5. Remember, we times along the branches. Times by 7/10 is going to be equal to 28 over 50, which simplifies to 14 over 25. Okay, moving on to the last question today. We are told Tina has 2 bags of counters, bag A and bag B. There are 5 red counters and 3 blue counters in bag A. There are 4 red counters and 5 blue counters in bag B. She takes out a random from each bag. Complete the probability tree diagram. Okay, so in bag A, we are told there's 5 red and 3 blue, meaning there's a total of 8 counters. So 8 is our denominator. The probability for red, therefore, is going to be 5 out of 8. So we can fill that in here. And we know that they're supposed to add to 1. So 5/8 plus 3/8 gives us our 1. Okay, looking at bag B, there is a total of 9 counters, and therefore the probability of 1 being red is 4/9. Then 1 minus 4/9 is 5/9, so we can write it in here and then fit it in similar down there. And that is our completed probability tree diagram. And we're told to work out the probability that Tina takes 2 blue counters. This is going to be 3/8 times by 5/9, because we're going from blue to blue, timesing along the branches. So this is going to be 15 over 72, which is going to be, does it simplify? Yeah, it simplifies to 5 over 24. Okay guys, that's going to conclude today's video on exam style questions for probability trees. I hope you guys enjoyed. Hope you feel like your knowledge has been consolidated. As always, please make sure to like, comment, and subscribe, and I'll catch you guys in the next video. Peace.